Welcome back, pre-calc students, and I bet the question you're wondering is, if you take a look at this equation, systems of equations, there's not a single variable isolated for. We don't have a 1 all by itself, so substitution's not going to be our best method. So then the question becomes, how can I get rid of these? A good process is used by adding and subtracting the equations until one of the variables eliminates. This thus being named elimination. Excuse me, sometimes to eliminate is the actual word. The process is called elimination. So what we're going to try to do is get the coefficients to match up. It doesn't really matter which one. We can get rid of the x, we can get rid of the y's. But all we need is to have the absolute value of the coefficients be the same. We can either add or subtract, whether it's positive or negative, as long as the absolute values of the coefficients are going to be the same. The first thing that drew my attention was the 4x and the 3x. So to get those to have the same coefficients, I'm going to take this first equation, multiply by 3. When I multiply by 3, I get 12x plus 9y equals 30. And I do have to multiply on both sides of this equation. And I'm going to multiply this equation by 4. I always try to find the LCM, the lowest common multiple, least common multiple. It doesn't really matter. You can always multiply, but it's easiest if the numbers stay a little bit smaller. 4 times 3 gives me 12x plus 8y equals 4 times 13 halves. That becomes 2, so that's equal to 26. At this point, because we have the same coefficients, what we're going to do is we're going to subtract. When we subtract, what we're really doing is we're taking this 12x plus 9y and we're subtracting from it on one side 12x plus 8y. On the other side, what we're doing is 30 minus. Now, you would think that because this 12x is plus 8y is what we did on the left-hand side, we would need to do that over here on the right. But we know what that equals, so we can put in 26. It's the same thing. We're subtracting the same thing, but just in a way that helps us solve this problem. The way that we... Oh, I could leave that up. That doesn't really matter. The process-wise, you don't typically write that all out. You just kind of subtract them. 12x minus 12x is 0x, plus 9y minus 8y is 1y equals 4. In other words, y equals 4. Once we have y equals 4, we're going to go back. We're going to substitute in to come up with our other equation. It doesn't matter which one. You can even go back to the originals. In fact, that's what I'm going to do just because it's a little smaller. And I'm going to say that 4x plus 3 times 4 equals 10, which means 4x equals plus 12 equals 10, which means 4x equals negative 2, which means x equals negative 1/2. So my point, negative 1/2, comma 4, it's not a bad idea to go and check, plug them in. Negative 3 halves plus 8, 8 minus 3 halves gives me that 13 halves. So that's the process of elimination.